Hi and welcome to video 4 from the CA topic. This video is going to cover how catalysts actually affect the rate of a reaction and how we can use catalysts in industry. So let's start by looking at what the key term catalyst actually means. So this here tells us what it is. So a catalyst is a substance that changes the rate of the reaction but is not actually changed itself. So although it is in there and helping the reaction to happen, it doesn't change as a chemical. Your catalyst will be the same at the beginning as it is at the end. Nothing happens to it. So if you put your catalyst in, it will still be there at the end of the reaction. And how do catalysts do this? Well, the important part for this is catalysts actually provide a surface for the reactant molecules to bind onto. So if we look at this diagram right here, what we've got is we've got our catalyst. Our reactants come in and get stuck to the catalyst. And what happens is because they are now here in our intermediate, what we have is that they require less energy to react. And so they can now break their bonds easier. They don't need as much energy and those bonds will break. The key to this part is that it is lowering the activation energy. So we already talked about this in the first video of this topic. Activation energy is the minimum amount of energy that reactants need to break their bonds when they collide and cause a reaction to happen. If we have a catalyst, because we're bringing those reactant molecules closer together, they don't need as much energy, and so the activation energy comes down for that reaction. And if it comes down for that reaction, what we end up with is more particles with the activation energy. And more successful collisions. So those collisions will happen more often and we will get reactions happening because of that. So let's look at how the catalyst actually works. So when I talked about the catalyst lowering the activation energy, it lowers that activation energy because it gives the reaction an alternative pathway. So another route for the reaction to happen over. That other route has a lower activation energy. So by giving it another way to react, it's lowering the activation energy, which brings the rate of reaction up. I said this before, so I'm going to repeat it again. It means that we have more of the particles with enough energy to break their bonds. If there's enough energy for them to break their bonds when they collide, they will successfully produce reactions. Now, a key skill that you guys are expected to have for exams is the ability to draw an energy level diagram. Now, this is part of the C7 topic on energy changes, where you learnt about exothermic and endothermic reactions. And remember, all of our energy level diagrams must have a reaction line and must have a products line. They have to have our activation energy, and there's one missing off here that they don't have. That would be the energy here, and that is your overall change. Okay, guys? So that's what happens between the reactant bonds breaking and the product bonds forming. So if we look at our diagram here, what we can see is if we have our reaction happening without a catalyst, the activation energy is higher. That means less particles will successfully react. If we look at our reaction with our catalyst, we've got a smaller line, less energy is required, the activation energy is lower. And what that means is more particles are going to successfully react. And so we'll end up with a higher rate. Okay, so why is this actually useful? The whole aim of a chemical company is to make profit. If you are a company that are producing chemicals to sell, you want to make as much profit as you can. The only way to make that profit is to reduce your cost. So if you have a chemical reaction that you want to have happen faster so you can produce more product, you would normally have a very high temperature or a high pressure to force that reaction to happen. If you have a high temperature and a high pressure, you're going to have to pay for that. You're going to have to use fuel, burn it to heat the place up, or you're going to have to use some form of energy to create the pressure. If you use a catalyst, however, what we end up with is we can reduce the temperature and pressure that you would have to put that reaction under. If you reduce the temperature and pressure, you reduce the energy requirements. And if you reduce your energy requirements, you reduce the cost of fuel. So if you can make more chemical for less money, you can make more profit. Okay, guys? Another thing you need to consider is the type of catalyst that you're using. Lots of our catalysts are made from transition metals. Transition metals are normally expensive. So we're looking at things like nickel, gold, iron, potentially even copper. It depends on the reaction that we're looking at, which transition metal we pick. And if we're using a transition metal, there aren't that many of them around. They are what we would call a limited resource. It's finite. They're eventually going to run out. So why do we use them if they're expensive to obtain? The reason we use catalysts and transition metals as catalysts is this. They are not used up by the reaction. Because they're not used up by the reaction, you can use them multiple times. So you can put them in your reaction vessel and keep using them again and again. So you get multiple uses out of one transition metal block. Eventually you will have to replace it, but by the time you've done that, you've actually made so much profit, you've covered the cost of the expense to buy the transition metal. So catalysts are used by companies to make more money. They can produce much more product in a shorter space of time for less cost. And if they can produce it for less cost, they can then make more money by selling it. Okay, guys, so an example of a catalyst that you lot would have heard of is the one in your catalytic converter for your car exhaust. So if we look here, what we've got is we've got a solid catalyst. And what happens is our catalyst has gases passed over it. Okay, so your car burns its fuel. The gases that come out of your car engine are down here. They will go in through your catalytic converter, and when they hit this part, the honeycomb structure, it will allow the toxic gases to react and change into something less harmful. So when we're talking about our catalysts, they're not just used for making products, they can also come in handy in your everyday life. Every car in our country now that burns a fossil fuel must have a catalytic converter attached to it. When your car goes for service, that catalytic converter is checked, and if it's not producing the correct versions of these gases here, and it's not producing them in the right amounts, you have to pay to get it fixed. Now, one thing I do want you to realise about this is the structure of our catalyst. It is a honeycomb structure. Okay, guys, so what that actually means is you have your solid catalyst like that in there. If we were to look at it from that view, we would see these honeycomb structures like this. And what they are is the gas travels through, they're hollow, so travels through there. What that actually does is increases the surface area of the catalyst, okay? And what that means is, like we learned in a previous video for this topic, if we have a higher surface area, we can have more reactions. And if we can have more reactions, then we get a faster rate. So a lot of the time you will find that your catalysts will have huge surface areas. They will have honeycomb structures or other structures like that that create hollow tubes for your reactants to bind onto and then react. And by doing that, we get more reactions happening at faster rates. So our catalysts can increase our rate of reaction by exponential numbers. Right, guys, that's everything that you need to know for the topic on catalysts. So remember, a catalyst increases the rate of a reaction by decreasing the activation energy. It gives the reaction an alternative route so that they can react at a lower energy level, breaking their bonds and forming the product. And they're most useful in industry because they allow us to reduce the cost of making that product and make more profit that way. Okay, guys, thank you for listening and watching this video, and I will see you again soon for lesson 5 of the C8 topic.